Today is Monday, February 9th, I think. Yeah. And this is Algebra 2. And we're starting on page 263 in our book. It is section 5-8, the second to last section in this really huge chapter. It's called Radical Equations and Inequalities. And this section is finally where you get to use all these square root rules and important stuff. So it's solving equations that have radicals in them, like square root of x equals 2 and stuff like that. Like if we have 2x equals 8, how do we solve?
Divide by 2.
Right. So if you have the square root of x equals 2, how might you think we'd solve that? If we did division to undo multiplication, what do you think we got to do to undo square root?
Oh, square it.
Yeah, we got to square. And remember, it's the square of both sides. So remember when I kept telling you the square root of something squared is that something? Well, the opposite is true, too. The square of a square root is also that something. So, for instance, in the equation, the square root of x equals 2, squaring both sides gives you the square root of x squared equals 2 squared, or x equals 4. Okay? That's all this is about today, is solving equations by doing the inverse operation. And I'll give you a hint before we get started. If you have something like the square root of x closed radical minus 2 equals 4, you can't start squaring until you get rid of all the extra signs outside of the radical. So you'll see what that is in one of these examples. I think the first one, actually. So I'm just going to start reading the paragraph below the box about how computer chips are made out of silicon, which is in sand, where it says in big capital letters, solve radical equations. It says equations with radicals that have variables in the radicands, and of course the radicand is what's inside of the radical. They're called radical equations. To solve this type of equation, raise each side of the equation to the power equal to the index of the radical expression, i.e., raise the equation to the power of the root that you're given. So to solve a cube root, you would cube everything. To solve a fifth root, you would fifth everything. Things like that. It doesn't matter. Whatever root you have, because remember, the fifth root of x to the fifth is x. Okay? It's the same thing like the square root of x squared is x. Alrighty. Let's look at example 1. Solve a radical equation. It says, solve the square root of x plus 1 and root plus 2 equals 4. So this is what I was talking about at the beginning. If there's a plus 2 hanging out all by itself, you've got to move it over to the other side first. Otherwise, you'd have to FOIL. You really want to FOIL? Nah. No. So then you would rewrite it as the square root of x plus 1 minus 2, or plus 2 minus 2 equals 4 minus 2, i.e., the square root of x plus 1 equals 2, because 4 minus 2 is 2. Well then, we can do what we said we were going to do, and square both sides. So what's the square of the root of x plus 1? Okay, this is where all that stomping around I've been doing with you guys. The square root of something squared, or the square of a root. It's just what's inside. So the square of the square root of x plus 1 is just x plus 1. Okay, you see it? It's about line 3 in the example, Stormy, where they have parentheses, where you see the open paren. Should be a little open paren starting line. So open paren, open root, x plus 1, close root, close paren, to the power of 2. So remember, the opposite is true. So if you have something inside and it's squared and square rooted, you get out the radicand, in this case x plus 1. Well, then it's like once you know that, it's like regular regular algebra. What you just have x plus 1 equals 4. Well, you subtract 1 from both sides and get that x equals 3. And it wants you to check. So, of course, and this is really important because remember, we can't have negatives under any even root. But that's okay because 3 plus 1 is 4, and the square root of 4 is 2, plus 2 is also 4. So if you were to get a negative under the radical, this wouldn't work. That's what's coming up in the next example. Does that make sense? You take the equation, both sides of the equation, to the power of your root, and that will clear out the radicand. Okay? And then you solve like you would in regular old algebra. But this next part is where you have to be really careful. Alright. I'm reading the paragraph below the example. When you solve a radical equation, it is very important that you check your solution. Sometimes you will obtain a number that does not satisfy the original equation, such a number is called and this is my favorite, extraneous solution. I just like that word. An extraneous solution. You can use, of course, a graphing calculator, and we're going to get there, to predict the number of solutions of an equation, or to determine whether the solution you obtain is reasonable. Well, don't worry. I won't assign any crazy ones that you won't know for sure. Alright, example 2. Extraneous solution. Okay, here we go. Solve. The square root of x minus 15 equals 3 minus the square root of x. Okay, this one's a little trickier because, one, you have the square root on both sides of the equation. So that whether you move the 3 over or not won't help you any. Okay, because you have a square root on each side, so you're going to have to just square both sides. Now, this is where you have to be really careful. The left side, x minus 15 under the square root squared, is just x minus 15. However, on the right side we have a 3 minus the radical x. 3 and minus radical x aren't like terms. So, like we did in the prior example, we have to FOIL that thing. Yep, because one's a number and one's a radical. So it's just like if you had x plus 2 in parens squared. Here we have 3 minus radical x in parens squared. So you have to do first, outer, inner, last. Well, first is 3, right?
Mm-hmm.
On your paper, Stormy, you would write it out. Open paren, 3 minus square root x, close, open, 3 minus square root x, close. Because remember, squared in parentheses means you have 2 of them, right? Yeah. So 3 times 3 is
9.
9. Negative radical 3 times negative radical 3. Negative radical x times 3 is negative. Let me repeat. That sounded all funny coming out of my mouth. 3 times negative radical x. You're doing first, outer, inner, last. It's just negative 3 radical x, right?
Mm-hmm.
And your last, or your inners, another negative radical x times 3. What's that? Same thing?
Yep.
Yep, so we have 2 negative 3 radical x's. And your last, what's the square root of x times the square root of x?
Correct.
Nope, careful.
Correct.
Yes, Stormy x. So finally, on that right side, you have 9. What's negative 3 radical x minus 3 radical x? Combining the middle.
Minus 6.
Yeah, minus 6 radical x. So on the right side of the equation, you would have 9 minus 6 radical x plus x for your first, outer, inner, last. Whew. Okay? And remember, your left side was just the square root of x minus 15 squared, which is the same thing as x minus 15. Because again, when you square root something squared, or vice versa, you get the radicand out. So we finally have x minus 16 equals 9 minus 6 square root of x plus x. Ew. Now we're going to do some like terms. Well, luckily for us, we have a positive x on the left and a positive x on the right. So when we subtract x from both sides, they go away. Right?
Yep.
Yep, and then we have a negative 15 on one side and a positive 9 on the other side. So we subtract 9 from both sides, and that's why we're left with negative 24, because that's what negative 15 minus 9 is, equals negative 6 radical x. Whew, okay, we got to keep going. Now we got to divide both sides by negative 6, because remember, you can't have any funky numbers hanging out when you only have one square root there. We want the square root of x to be by itself, just like we want x to be by itself. So negative 24 divided by negative 6 is 4. And we only have the equation, the square root of x equals 4. So therefore, since we're going to have to square it again, right? That's the only way to undo the square root. So then we have 4 squared equals the square root of x squared.
Okay.
Right? 4 equals the square root of x squared, just to get rid of that darn square root sign. And so we have 4 squared is 16, and the square root of x squared, x. So x equals 16. But remember, we have to check. We have to check. So we go all the way back up to our original equation. Okay? And we plug in 16 for x. So in the first radical, we have the square root of x minus 15. Okay? The square root of 16 minus 15 is the same thing as the square root of 1. Well, the square root of 1 is 1, right? So on the left side, we get a 1. On the right side is 3 minus the square root of x. So 3. So what's the square root of 16?
4.
Right. So on the left side, we have 1 equals 3 minus 4, i.e. 1 equals negative 1. Is that going to work? It's the top of the
No.
No. So you can follow it. It's at the top after the page break. They did it for you. 16 minus 15 under the negative 1 does not equal 1. So therefore we say, oh, this is an extraneous solution. And then you're done. That was a lot of work to find out that there was no solution, right?
Yeah.
What a mean book.
Is that all you can do in that case? Just
Yeah, then
say-
you're done. That's it.
If that were on a test, would we just say no solution, or would we have
You
to
would say extraneous solution.
extraneous solution?
Because it does solve, it's just it doesn't work. Yeah, good math grammar would be awesome. So just say extraneous solution. Okay, that's half the section. Does anybody have any questions so far? You sure? Because I'm going to move on. All right. All right, I'm looking at the paragraph on this, right below the check on page 264.
You're welcome at the last one.
One more little thing to learn. Cube rooting. Okay.
Oh.
Yep, right below the check of the, past the page break, Stormy.
Okay.
And then past the check, and then there's a little paragraph that says, you can. Alright. You can apply the same methods used in solving square root equations in solving cube root equations. Indexes, as they say. I like to say roots because index sounds so blasé. Anyway, remember that to undo a square, you have to square both sides. So to undo a cube, you have to cube both sides. To undo a cube root, you have to cube both sides. To undo an nth root, you have to do to the power of n each time. Alright, let's see what they did. Example 3 says, cube root equation. Alright, here we go. Remember, even though it's in power form, it's still a root. So this is solve 3, open paren, 5n minus 1, close paren, to the 1/3 power minus 2 equals 0. 3, open paren, 5n minus 1, close, to the 1/3 minus 2 equals 0.
I have a question.
Mm-hmm.
When it's written that way, the 3 outside the parentheses, would that be included under the cube root, or would that
No.
be? It's not.
It is not. It's correct.
Okay.
You do not include it because it's not inside. If it said 3n, or well, in this case it would have been 15n, you would include it. But since it's outside, the power does not apply.
Okay.
So we start out this one by getting rid of all the extraneous stuff. That includes the minus 2 and the multiply by 3. So, and of course it says, in order to remove the 1/3 power, or cube root, because remember, power over root, you must first isolate it. So again, how do we get rid of a negative 2?
Add.
We add 2 to both sides. So then we're given, I'm looking at the first line of, right after that little paragraph, Stormy. So when we add 2 to both sides, now I'm on the second line, it's 3, open paren, 5n minus 1, close, to the 1/3 equals 2, right? Because 0 plus 2 is 2. And then the third line down, we get rid of the 3 by dividing both sides by 3, of course, right? So you have open paren, 5n minus 1, close, to the 1/3 equals 2 over 3, right? Because we can't, 2 and 3 don't divide. All right. So to get rid of a 1/3, we've got to multiply the power by 3, right? Because 1/3 times 3 is 3/3, which is 1. Okay? So what they did, they put it all in brackets. They put the whole thing on the left side, the 5n minus 1 to the 1/3 in brackets cubed. Okay? And that's just so you can keep everything separated. Equals 2/3 cubed. Okay? Well, again, what's the cube root of something cubed? That's something.
Not something.
Right. So on the left side, you're just left with the radicand, which is 5n minus 1. And on the right side, what's 2/3 cubed? Anybody know? How do you cube a fraction? Right, you cube each part. You cube the numerator. 2 cubed is 8, and you cube the denominator. 3 cubed is 27. So you're left with 5n minus 1 equals 8 over 27. Oh boy. And then we've got to add 1 to both sides, but remember, that's a fraction. So how many 27ths is one whole? How many 27s do we need? How many 27ths does it take to make one whole number?
26.
27 of them. Not 26, but we want one whole, not 1/27, right? One whole. So how many thirds does it take to make one whole?
3.
Right. So the same applies here. 27 27ths makes a whole. So you could rewrite it in your head. The book skips this step, but if you wanted to, you could rewrite 5n minus 27 over 27 equals 8 over 27. That's a good idea, I think. So that you can keep all your rules in your brain and then have it written down and you don't forget. Okay? So 5n minus 27 over 27. And to undo a minus 27 over 27, we have to add it to both sides. Yeah. Then we get 5n equals 35 27ths. Okay? And then we have 5n equals 35 over 27, and they decided to be smart and cancel. Because how many times does 5 go into 35?
7.
Right, and they left the denominator alone. So your final answer is this crazy 7 over 27. Okay? Because when you divide by 5, you can cancel the 35 and the 5. So that's why they had. So you, again, on your paper, you rewrite it as n equals 35 over 5 times 27, closed fraction. Because that's how you divide by 5 in that case. And then that's how they cancel. Okay, and then they want us to check this nasty thing. Okay. So when they plug in 7 over 27 into this whole monster, they just replace the one n as 7 over 27. So I'm looking at the second line of the check. 3, open paren, 5 times 7 over 27 minus 1. Alrighty. Now, they skipped a whole bunch of... They always do that. Okay. They skipped a whole bunch of stuff. They would get 35/27 again when you multiply. Minus 27 over 27. Right? Because there's another minus 1 again. So 35/27 minus 27 over 27 is 8/27. So the third line down, that's why it's 3 to the 8/27 to the 1/3. Now, again, you can cube root, because it's 8/27 cube rooted. Okay? The cube root of, and you can separate them. So you could rewrite 3, and then leave your 3 out front. You can't move it. The cube root of 8 is 2, and the cube root of 27 is 3. So you could rewrite that whole little bit there as 3 times 2/3. And you finish it up. 3 times 2/3. Well, you can cancel the 3 and the 3. And you're left with 2 minus 2 equals 0. Is 2 minus 2 0? Yes.
Yeah.
So that check was testing all the mathematical algebra or arithmetic skills you possibly own. It's adding fractions, multiplying fractions, using your cube roots, all of it. That answer checks out. It's 7 over 27. It worked because we didn't get a weird number. All right. We have one more thing to pummel our way through today, but we're going to spend today and tomorrow practicing. Okay? I probably will assign 1 or 2 as homework to come back with so that you have questions for me tomorrow, and then we'll finish the rest tomorrow. Okay? So one last thing. Do you think you can handle it?
Maybe.
Maybe. She says. All right. Well, I'm reading the very last couple of lines on the page. Here we go. Now, we solved inequalities before. Now we're going to do it with our scary square root. Solve radical inequalities. All right, here we go. You can use what you know about radical expressions to help solve radical inequalities. A radical inequality, of course, is an inequality that has a variable in the radicand. So nothing different, just like a radical or equation, except with less than or greater than in between. So example 4 is on the top of the next page, just after the page break. Example 4 says radical inequalities. All right, here we go. It says solve 2 plus open root 4x minus 4 close root less than or equal to 6. Now, the same rules apply. Since there's that 2 hanging out, we have to get rid of it first. It's not inside a radical, so we can totally move it to the other side. And therefore, isolate. What we call this is isolating the radical. Get it all by itself. So, and since it's a square root, we can square everything when we get there. All right. So when we move the 2 over to the other side, we have this square root of 4x minus 4 is less than or equal to 4. That's not too bad. Then we square both sides. Oh, there's one thing. Excuse me. There's one thing that we have to check. Remember what I said at the beginning of the section? It's an even root, right?
Mm-hmm.
We can't have negatives in our even root, right? No negatives. None. So we have to solve a mini equation before we even get started. Okay? Because we don't want the quantity 4x minus 4 to be less than 0. If that is less than 0, we have a negative, obviously, in the square root, right?
Mm-hmm.
So we solve it. What's 4x minus 4 is greater than or equal to 0. That's how you would write your little mini equation. You take the radicand and set it greater than or equal to 0, because if it's less than 0, obviously it's a negative. And when we solve, 4x minus 4 is greater than or equal to 0, well, we move the 4 over. Then that gives us 4x is greater than or equal to 4, because 0 plus 4 is 4. And then we divide both sides by regular 4 and get x is greater than or equal to 1. So within our solution, whatever we get when we actually solve this thing, x cannot be greater than or equal to 1. If it is, we'll get a negative. Alright, so here we go. Now we're actually going to solve this thing. So when you
X can't be what?
greater than or equal to 1.
X can't be greater than or equal to what? X can't be
Less than.
Oh, X can't be less than.
The book says greater, which is strange. Alright. Alrighty. Well, because,
Oh, X can't be less than or equal to 0.
no. Because think about it. If say x was negative 2, right, we'd have negative 8 minus 4, and that's negative 12. We can't have that inside the radical. So x has to be greater than or equal to 1. So x can't be 0, x can't be negative 1.
Oh, but just in general.
Right.
Oh.
I mean, you have to do that, because if you plug in anything less than 1, you will get a negative in your radicand, and you can't have that. It's not solvable that way.
Oh, I'm sorry. My question was the radicand can't be less than or equal to 0.
Right, yes.
Oh, okay.
So that's why we set it up right here.
Okay,
4x minus 4 is greater than 0. Yeah.
Can.
Yes. The radicand can't be less than 0 for any even power.
Yeah.
2, 4, 6, 8, 10, 12, it doesn't matter.
Less than or equal to 0.
So that's why x must be, in our solution, greater than or equal to 1. Because if it's 2, we're good. But 4 minus 4 is 0. Alright, so now that we know that, you have to write it down on your paper to keep a note. X must be greater than or equal to 1 in order for this to work. Because when we solve this, we might get answers that are extraneous, our fun word. So now solve 2 plus, open root, 4x minus 4, close, less than or equal to 6. Now we do what I was saying earlier. We move that 2 over. It's a positive 2, so we subtract 2 from both sides and get the square root of 4x minus 4 is less than or equal to 4, because again 6 minus 2 is 4. Now we have isolated the radical, so now how do we undo a square root?
Square it.
Right, we square both sides. So again, when we square a square root, you're just left with what's inside. So 4x minus 4 is less than or equal to 4 squared, which is 16. Okay, so we have 4x minus 4 is less than or equal to 16. Then you add 4 to both sides as usual, and you get 4x is less than or equal to 20, and you get x is less than 5 finally when you divide by 4. Now, but remember, we had an additional restriction. X can't just be less than or equal to 5, because that includes all the negatives, right? It does, because it doesn't care, right? Less than or equal to 5 goes off into negative infinity. So when you do this, you actually have to tell me that x is greater than or equal to 1, but also less than 5. Therefore, your answers are 1, 2, 3, and 4, right? Because it says, and 5, because it says less than or equal to. So the only possible solutions you could have to this are 1, 2, 3, 4, and 5. Anything less than that will give you a negative under the radicand, which we've learned doesn't make any sense, because you can't find the square root of a negative. Now in this table, they went and checked them all. They chose 0 just to show you in this table. When x is 0, you get the square root of negative 4. We don't have that. When x is 2, we get 4. That works. I'm just glancing at the table. But when x is 7, we get approximately 6.9. That also does not equal is not less than or equal to 4. So the trick to this one is to remember that you have to check your radicand first, and then know that that's a first restriction, and then your answer, when you actually solve the equation inequality, is the second restriction on your solutions. Okay. All right, and it tells you right here in the key concepts box. All right. To solve radical inequalities, complete the following steps. Step 1. If the index of the root is even, identify the values of the variable for which the radicand is negative. So that's what you do first. If it's a cube root, do we have to do that? No, we don't, because we can have negatives under a cube root. Step 2. Solve the inequality algebraically. And finally, Stormy's bell means we have 5 minutes. Step 3. Test your values to make sure that you have the right solutions. So in our case, we would check that 1, 2, 3, 4, and 5 were all solutions. All right. So I'm just going to assign you, since there's only 5 minutes, a couple of homework problems. Number 4, 8, and I'm going to make it 3. Number 4, 8, and come on, where are you? Radical. 4, 8, and 10. Those are your homework problems for today. And tomorrow we're going to practice. So I want you to do them and come back with me for questions. Okay? 4, 8, 10. Okay? Those are yours to do at home. And then tomorrow we're going to practice more. And hopefully you doing these at home will help you have questions for me tomorrow. Okay?